Hello my dear NEET aspirants and welcome you all to your own platform PW. This is your physics mentor Gaurav Tiwari and today we are going to complete the chapter of motion in a plane in one shot. My dear aspirants, for crystal clear understanding of this chapter, I have divided it in 5 parts. So be it the understanding of vectors or the numericals on projectile motion, everything will be crystal clear to you by the end of this video. Just stay till the end of this lecture and you will have the absolute clarity of each and every concept. I'll be sharing a free DPP for your practice along with the lecture notes that you can access on the app through the link given in the description. My dear aspirants, PW is a constant companion to achieve your ambitions, and you can also feel the difference in your preparations with our precisely designed courses. Just explore the app through the link given in the description and achieve anything you want. Now let's start the chapter. Alright, so let's start right away with the chapter, and there are 5 parts in this chapter, and in these 5 parts we can understand the concept of motion in a plane in a crystal clear way. The first part of this chapter is vectors. So we will talk about the basics of vectors, right? That will help us to understand the rest of the physics really well, right? Okay, so after that we will talk about the terms of motion in 2D in the second part. Then this is the main part, projectile motion. This is where we are going to invest most of our time. Then we will talk about some problems of relative motion in 2D. We will not be investing so much time on relative motion because that is mostly a JE topic, but sometimes like once in a while they ask questions from this topic as well. That's why I have included it. And finally there is circular motion. So I have made a separate video for circular motion. So you'll be reading that over there. So this is going to be in this particular chapter, and every single thing from this chapter will be cleared in these 4 or 5 parts, right? So let's understand that vectors, right? This is the first part, vectors. So we'll talk about what is scalar and vector, what is a vector addition, what is product, and what is the meaning of unit vector and displacement vector, right? So let's talk about that. So here you have a scalar. So right now you see that there are 2 guys. They are simply moving in a random direction like this, right? So Mohan went 1 kilometer but didn't find the school. So you see that Mohan, this is Mohan's home, this is home, and this is the school. So Mohan went 1 kilometer but didn't find the school because the direction was wrong, right? Because the direction was wrong. And as you know that scalars are the quantities that have only one thing, magnitude, but they don't have any direction, right? Direction is missing. So here, Ram should have told Mohan that you have to go 1 kilometer, but in which direction? If he had done that, he would have reached to the school, right? So yeah, so a scalar is simply a quantity that has only magnitude and no direction. Most of the kids already know that, right? But there are just basic things, just a brush up of things, right? So it is just described by just a number, right? My mass, my mass is, let's say, 75 kilograms. So this is just a number, right? Okay. All right. So scalars can be treated with any common principle of algebra, right? So yeah, speed, volume, mass, these are all scalars. What is vector? Vector is something that has magnitude as well as direction, right? Magnitude as well as direction. So right now you see that he is moving in 1 kilometer toward east, and which is why he knows that 2 things, magnitude as well as direction, right? So yeah, so vector is something that has both magnitude and direction. And vector quantities are like force, velocity, and all these things, displacement and all, right? Which of the following is not vector? Speed, momentum, force, acceleration. So first of all, quickly tell me which of them is not vector. Simple. Force is a vector quantity, acceleration is a vector quantity, momentum is a vector quantity, it is speed which is not vector. So option A is correct. Let's move on, talk about this part. The temperature of hall is 28 degrees Celsius. It is a scalar vector or can't say anything. So think about it. 28 degrees Celsius is the temperature. You cannot say 28 degree toward east or west. It's a scalar number. So yeah, it's a scalar quantity. Similarly, now you talk about vectors. Whenever you want to represent vector, there are 2 things. One, you have to represent the magnitude, that is represented by the length of the vector, and the direction, that is represented by actual direction of the vector, right? So this is simply the graphical representation of this thing, right? Very simple part. That's why we are not going to invest so much time on it. So this is how you represent vector. The length, how big you draw the vector, that is representing the magnitude. If you draw the exact half vector, so this vector is going to be half of the previous one in the size. That is why the magnitude is going to be the half in the second case. Right. So right now you can say that, right, vectors we can represent in 2D or 3D space, right? So depending upon what kind of situation we have. So yeah. represent graphically displacement of 50 kilometers, 30-degree east from south. So you see that, let's say that this is how you are writing east, west, north and south, right? 30-degree east of south. So this is how you have to move 30-degree east of south, right? And you have to move, you have to represent 50 kilometers. So let us say that 1 centimeter is 1 kilometer. So 50 centimeter is 50 kilometer, right? In your notebook, you can say 10 centimeter is 1 kilometer. So yeah, yeah. So 1 centimeter is 10 kilometers, which is why you can draw a smaller vector, right? So you have 50 kilometers right now, right? And this is how you can represent it. Okay. Now equal vectors. Two people can have same mass, right? Both of them have 75 kilograms. The direction doesn't matter, it's just a number. Two people can have same height, the direction doesn't matter. But what about equal vectors? When can we say that two vectors are equal? My dear kids, we can say that two vectors are equal when their magnitude and directions both are equal, right? When their magnitude and directions both are equal. When A vector is equals to B vector means their magnitudes are same. Their magnitudes are same. That is, magnitude of A vector is same as magnitude of B vector, and direction is also same. Direction is also same. All right. Okay. What is negative vector? When you flip a vector, it becomes negative. When you simply flip a vector, it becomes negative vector, right? Parallel vector, two vectors are parallel, then their magnitude need not to be the same. For example, this vector and this vector is also parallel vector, but they are not they don't need to be same, right? Anti-parallel vector, when they are flipping against each other, so one is towards right, so other has to be towards left. So zero vector means the vector that has no magnitude is zero vector, right? So yeah. Multiplication with a positive scalar. So right now, how can you multiply things with a vector, right? So you see that when you simply multiply a vector with a number, a scalar quantity is just a number, the magnitude rises. So if you multiply this vector, let's say this is the A vector, you multiply that by 2, the length will become 2 times, so it become 2A vector, right? So multiply vector with a negative scalar. So whenever negative sign comes up into the picture, the direction flips up simply. So this was the vector. You have multiplying with the -2. So with the minus sign, it will be flipping itself, and then with the 2, it will double the magnitude. So it will become like this, -2A, right? So shifting or sliding a vector. So you can always shift or slide the vector. That doesn't change anything. For example, this is the vector, right? And you want to represent another vector on top of it. So let's say that another vector is written like this, right? You can also shift the vector anywhere if you need, and you can also draw the same vector from here to this place, right? So yeah, it depends on your need entirely, right? So yeah, right now you see that angle between two vectors. So this is slightly important, right? Angle between two vectors. How would you take the angle between two vectors? So right now you see that we have two vectors. Can we say that the angle between them is this theta, or angle between them is this theta? Which of them is correct? We can say whenever we have two vectors and we want to find the angle between them, we have to add them head to head or tail to tail, right? So you see that this is the vector, this is head of the vector, this is tail of the vector. So whenever you have this situation going on, you see the tail of the vector and head of the vector, they are coming up together. We don't want this situation, right? If you want to measure the angle, you will shift it, because shifting will not change anything. So you will shift it like this. So it will become like this, right? You just shift it from here to here. And then once you shift it, it will become tail to tail, right? It will become tail to tail. Now, once two vectors are touching head to head or tail to tail, then the angle between them is the smaller angle between them, right? So right now, you see that these are the two vectors touching tail to tail, right? So the angle between them. So there are two angles that you can find between them, right? One and the second one, outer one. So which angle you have to take? The inner one, the smaller one, right? Let's look at this particular part, angle between two vectors. Here you see that these two vectors are not touching head to head, right, or tail to tail. So you will shift it like this. So once you have shifted it like this, you shift it like this, right? So what will happen? Now they are touching tail to tail. So this angle is 120, the other one would be 360 minus 120. So you see that the smaller angle will be taken. The angle between them is going to be 120 degree, right? Right now you see that there are two vectors. Look at that. What will be the angle between them? So you see, you have to shift the vector so that they are either head to head or tail to tail. So you see that. Shift the vector B like this and like this. So you see, this is a vector A, right? And keep it same direction, you have to keep same. So this is vector B, right? So right now you see that if it was 45, the remaining angle was 180 minus 45. So you see this angle is 180 minus 45. 180 minus 45 is 135, right? All right. I believe the idea is very, very clear. Right. So now there are two angles between A and B after shifting the B so that they can join tail to tail. 135 and the other angle outside. So the smaller angle when they are just touching head to head or tail to tail is the correct angle. So 135 is going to be the correct angle. If the following in the following diagram, find the angle between A vector and B vector. So A vector, B vector, right now they are not touching head to head or tail to tail. So you have to shift either B so that they touched head to head, or you can shift A so that they can touch tail to tail. In both situations, you can get the same thing. So you have the B vector exactly same. You are shifting A vector so that the tail touches, right? So the remaining angle would be this angle, 50 degree. 180 minus 30 is 50. Right? This is going to be the case. The outer angle is going to be 130 degree. I believe the idea is very, very clear. Right. So option C is going to be the correct option right now. Now you have the unit vector with you. Right. What is unit vector, my dear kids? We can say the unit vector. We can say that the unit vector is simply a vector of unit magnitude in the direction of a given vector. So right now you see that we have vector A. What will be the unit vector in this situation? We just take a vector of unit magnitude, right, in this direction, and that will be the unit vector in a given direction of vector A. How will you find the unit vector in any vector's direction? Unit vector in any vector direction will be entire vector upon magnitude of that vector, right? Entire vector upon magnitude of that vector is a unit vector in a direction of given vector. Very simple stuff, right? Standard unit vector, you see that along x-axis, the standard unit vector is I cap. Along y-axis, it is j cap. Along z-axis, it's k cap. Right. Similarly, along negative x-axis, along negative y-axis, along negative z-axis, just minus sign will come up. Components of vector. This is again a very useful thing for us to have. Components of vector. Whenever you want to find out the effect of a given vector in two desired direction, we will take the component to vector. And understanding the projectile motion is impossible if you don't know how to take the component of the vector, right? You see that, for example, there is a body and a force of 100 Newton is acting towards right and a force of 20 Newton is acting towards left. Basically, we can tell that a net force of 80 Newton is pulling the body towards this way, right? Okay, so right now what you have done, you are finding the resultant of this two, right? Okay, similarly, you can also have two forces, force number 1, force number 2, and you can replace these two forces F1 and F2 with one single force. Let's call it net force, right? In place of using two forces F1 and F2, you can only use the net force and get the same result, move the body in the same direction with the same velocity, with the same acceleration. Right. Now, my dear kids, we can say, if we do the opposite, let us say we cannot apply the net force. We don't have that much force available with us, right? Let's say that you want to lift a body, right? And that lifting requires, let's say, 5,000 newtons of force, and you alone cannot apply 5,000 newton of force, right? So what you can do, multiple people will join with you and they will add up that forces, and then the net force of 5,000 will be applied. Right now, that is called as addition of forces. That will give you the net force, right? Okay. So lot of forces can be added up to give you one force. The opposite is also true, right? The opposite is also true. A single force can be assumed to be composed of multiple forces, right? And generally what we do, right? Generally what we do, we take the two components of a given vector in two mutually perpendicular directions, right? Into mutually perpendicular directions, right? And then these things that constitute a given force or given vector are called as components of given vector, right? These components, all right, these vectors that can be assumed to be constituting a given vector are called as component of given particular thing, right? So in physics, whenever you break a vector into two parts, into multiple parts, these are all called as components. For example, a force of 100 Newton can be broken down with 10 Newton plus 20 Newton plus, let's say, 70 Newton, right? So we can have 3 people and apply the net force of 100 Newton, which was required. So you see that these 3 are the components of force, that is 100 Newton net force acting on the body, right? So the components need not to be in mutually perpendicular, but we can also have component in mutually perpendicular direction, right? And that helps us a lot whenever we try to understand projectile motion, right? Okay, so look into this situation. We have this OP vector going on with us, right? OP vector, you move x units along x-axis and y units along y units along this axis, y-axis, right? So it is x I cap plus y j cap. This is how you represent the OP vector, right? Okay. All right. So the magnitude you can find out simply the under root a component of I vector and component of j vector. This is the magnitude of a given vector, right? So you see that the x component of this particular vector is this, and the y component of this vector is this, right? You just simply say that x component is this and y component is this, right? This is it. All right. So look at this situation. A force of 20 Newton makes an angle 30 degree with the x-axis. Find both x and y component of the force, right? We have to find both x and y component of the force. So you see that a force of 20 Newton is acting, right? Right now, this is going to be the horizontal component and this is going to be the vertical component, right? So the horizontal component will become 20, let's say this is 30 degree. It is 20 cos 30. And in this triangle, you can say the vertical component is 20 sin 30, right? So cos 30 is root 3 by 2. Cos 30 is root 3 by 2. So 20 root 3 by 2, which is 10 root 3. That is going to be the horizontal component. Similarly, it is going to be 20 sin 30. Sin 30 is 1 upon 2. So it is going to be 10 only, right? So you see that horizontal component is 10 root 3, vertical component is 10. So 10 root 3 and 10, that is option A is the correct option, right? So I believe the option A is the correct option. Yeah. Magnitude of vectors. Magnitude of vectors, simply you see that OA vector is A vector. So this is how you represent the entire OA vector. It's A vector. So the magnitude is simply A only. So you just you can represent the magnitude of, if OB vector is B vector, then magnitude of OB is only B, right? Just remove the vector sign, and this is the notation for the magnitude of this thing, right? Okay, so finding the magnitude, if the vector is written in this format, x I cap plus y j cap, how will you find the magnitude? Simply take the under root of this component square plus this component square. Similarly, if you have in x, y, z format, if a vector A is written as x I cap plus y j cap plus z k cap, then the magnitude of A vector, or only A you can write, it is under root x square plus y square plus z square. Simple, right? What is the magnitude of this vectors? We can say that magnitude of this vector is under root 4 square plus minus 3 square. So it is under root 16 plus 9, which is 25, which is 5. Option C is the correct option. Addition of vectors by components. So we have vector A and vector B written in the component form. If you are adding them or subtracting them, simply you are dealing with their components only, right? So the components are added and I, j, k are placed, and similarly if you are subtracting them, components are subtracted. You see that ax and I, the coefficient of I and j are simply added or subtracted, right? A is this, B is this, A minus B. We can say for A minus B, simply subtract coefficient of A, x and I and I. So here you see that coefficient of I and I here is 3 and 3. So it will become 0. Coefficient of 0 I cap. Coefficient of j is 4 here and you have 7 here. So 4 minus 7 is minus 3. And coefficient of k is 5 here and coefficient of k is 9 here. So 5 minus 9 is minus 4. So answer is minus 3j minus 4k. Option B is the correct option, right? Position vector. Now what is a position vector? Simply, whenever you have a reference situation going on, so this is a reference axis x, y, z, and the point P is there, right? So how far is point P? Whenever you are measuring the point P, right, you are measuring it from somewhere, right? In the previous video, I've already told you that whenever you are measuring the distance of a point, you have to measure it from a particular place, right? So point P, the distance of point P is measured from somewhere, right? The distance of point P is measured from somewhere, right? So this is the reference axis, right? This is the reference axis, and this is the point P. How far you have to move so that you can reach to point P on the x-axis? Let's say that is the x units. You move x units on the x-axis so that you can go towards P, right? So it is x I cap. This is how far you move on the x-axis. How high you have to climb? Let's say you have to climb for y units, y times j cap, and let's say that the point P is above the screen, right? And so you are also moving z units in the z along the z axis. So this is a vector can be used to join the point O and P. So this OP vector that gives you the position of a certain point with respect to a reference point is the position vector of that particular thing, right? Okay. All right. And if the position is taken from a certain other point, if it is taken from the reference origin, then it is this, right? If it is taken from any other point other than origin, then you can simply subtract x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. This is the position vector. No problem with that, right? Triangle law of vector addition. So simply it's a graphical way of adding vectors, right? We have also added the vectors already. So if you want to add them graphically, add them first vector, from the head of the first vector, add the second vector, and then join head to tail. So this is the resultant, right? Okay. All right. So parallelogram of vector addition is very, very important. So you see that you have two vectors acting at an angle, right? And you want to find out what will be the net angle, net vector acting, because of them, right? You see that this is the first vector acting at point O. This is the second vector acting at point O. I can assume the remaining two parts by assuming two sides of parallelogram. The resultant will be the diagonal of that thing, right? Right. So let's calculate that diagonal. What will be the resultant of A and B? Resultant of A and B. So if you just solve and apply the basic trigonometry, the resultant of two vectors A vector and B vector is, right, the resultant of two vector A vector and B vector is, the magnitude is under root A square plus B square plus 2AB cos theta, and the direction of the resultant is acting at an angle alpha. The direction of the resultant is B sin theta upon A plus B cos theta. B sin theta upon A plus B cos theta. Very quick, we can understand this particular thing, right? There are two vectors. They are acting at a point. What will be the net force? Under root A square plus B square plus 2AB cos theta. And the direction is B sin theta upon A plus B cos theta. I believe the idea is very, very clear, right? Parallelogram and law of vectors, law of vector addition. So basically, we can simply do that. If two vectors are in the same direction, if you apply theta is 0 for the same direction, theta has to be 0, and you apply it, it will be simply addition of two vectors. If two vectors in the opposite direction, apply theta is 180, it will be minus 0, right? Minus 1, right? Not minus 0, minus 1. So you apply it, so R will be A minus B, because it will become A square plus B square minus 2AB, cos 180 is minus 1. So it will become A minus B whole square, right? So yeah, so this is how you will solve it. Now you will have multiplication of vectors. Multiplication of vector you can have in multiple situations. You can multiply a vector with a scalar number, so that will only change the magnitude, right? And you can also multiply a vector with another vector. So multiplying with a scalar, for example, you have to you are moving 20 meters towards east, right? And that is representing vector A. So if you are multiplying with 2 times, so basically you have to move 40 meter in the same direction east, right? Just magnitude is doubled. But when you multiply a vector with a vector quantity, right, there are two possible situations. You multiply a vector with another vector, and the result is also a vector, that is a cross product. You multiply a vector with another vector, and the result is a scalar, right? The result has no direction, then it is a scalar product or dot product, right? So you see that if vector, this is the multiplication with the scalar number, so you can simply multiply it, right? If two vectors are vector A and vector B, and you are multiplying them, right, such that the result is a scalar number, then their product is called as dot product, right? So you have A, B cos theta, that is the dot product of two vectors. So right now you see that cos theta is magnitude of multiplication of A dot B upon multiplication of their magnitudes, right? So yeah, if theta is 0, if the vectors have no angle, 0 angle between them, so then product is going to be maximum, dot product is going to be maximum, right? So yeah, properties of dot product. So you can say that dot product have these properties. Two non-zero vectors are there, then they are perpendicular only if A dot B is 0. So if two vectors are given, and you need to know that, check if these vectors are perpendicular or not, right? Vector A is given and vector B is given, right? So you have to know that if they are perpendicular or not. You just find A dot B, right? A dot B. If A dot B comes out to be 0, because A dot B is AB cos theta, right? Right, if A dot B is coming out to be 0, that means AB cos theta is coming out to be 0. AB cannot be 0, so cos theta has to be 0. Theta has to be 90 degree for that, right? So theta is 90 degree, then only dot product is 0, or the opposite is also true. If the dot product is 0, then only the dot vectors are going to be perpendicular, right? Okay, so yeah, so let's move on and talk about the next idea. A vector and B vector are given in the vector format, ax I cap, ay j cap, like that, right? And you have to take the dot product, simply multiply the coefficient, right? Simply multiply the coefficients and you will have the answer, right? You see that, multiply the coefficient, all other coefficients will cancel out, right? The resultant will only have the coefficient of x and x, y and y, and j and j. You see that? You multiply with ax, bx, I cap, ay, gy, j cap, I cap, j cap. So you see that product of two different unit vectors which are perpendicular. I cap is unit vector along x-axis, j cap is unit vector along y-axis. The dot product of them is going to be 0. So dot product of them is going to be 0. Similarly, dot product of j and I is going to be 0, right? So I, j, and these are all going to be 1, right? I dot I 1, j dot j is 1, k dot k is 1, right? So A dot B in this situation is going to be ax bx plus ay by, like that, right? If you have 3, then it is going to be like this, right? Two vectors are given, right? That this find the value of alpha if this vector is perpendicular to this vector. Now you know that if two vectors are perpendicular to each other, let's call this is vector A and this is vector B, and if two vectors are perpendicular to each other, that means their dot product has to be 0, right? Dot product has to be 0. That means the product of coefficient, right? Product of coefficient, here product is 1, coefficient is 1, here it is 2. So 1 into 2 is 2. Here is minus 2, here is alpha. So here is minus 2 alpha. Here is 1, here is 1. Here option is going to be 1, 0, right? Okay. All right. So you will have 2 and 1, 3. Alpha equals to 3 upon 2, right? Alpha equals to 3 upon 2. That is going to be the answer. Option A is correct. Addition and of dot product in physics. Application of dot product in physics. Where are you going to apply the concept of dot product? So in physics, dot product is extremely useful. You will find that f vector is f dot s. So f dot s is fs cos theta. These are all things you have, right? Similarly, momentum is f dot v, right? Okay, so these are all the dot products. Vector product of two vectors. Vector product of two vectors. So vector product of two vectors is simply when two vectors are multiplied and the resultant is also a vector. So you right now you represent that a vector dot cross v vector is ab sine theta, right? And the resultant is also a vector. So the direction of the resultant is this n cap. What is n cap? N cap is a unit vector in the direction of the resultant, right? Where is that unit vector? It is in the direction of a cross b. So right now it is pointing outwards. So the n cap has this direction. So a cross b, whatever quantity a cross b is going to give you, that will have a direction a cross b. That will have a direction towards perpendicular outwards of the screen in this situation, right? So yeah. Okay. So you have a cross b going on. So a vector is given, b vector is given, right? Their magnitudes, the magnitudes are 3 and 6. Angle between A and B is 30. Find the magnitude of A cross B. So you see that magnitude of A cross B you have to find out, right? A cross B is AB sine theta n cap. But magnitude is there, we can drop the n cap. So it is AB sine theta. So A is given 3, B is given 6. Sine theta is sine, sine Angle between A and B is 30, sine 30. Sine 30 is 1 upon 2. Option is going to be 9, right? So I believe the idea is very, very clear. Right. So that's pretty much everything about the vectors. We have simply revised what the concepts of vector, right? We have the major concepts that we have to keep in our mind is how to take the components of the vector, right? If we are taking the components in two mutually perpendicular direction, the horizontal component is going to be a cos theta and the vertical component is going to be a sin theta, right? In this situation. So I believe the idea is very, very clear, right? Let us move on and talk about the next part. What is the next part? That is the terms of motion in 2D. Again, it's going to be very, very simple part, right? And then we will talk about the projectile motion in great detail, right? So let's talk about the second part, which is the terms of motion in 2D, that the distance, displacement, and all those things in 2D, right? Simple problems. We will talk about that, right? Okay. So now let us talk about the second part of the chapter, which is the terms of motion in 2D. We have already seen what is the position, displacement, and distance, and speed and velocity and acceleration. But so far we have understood all those terms in one dimension, right? But here the particles are going to move in two dimension, and we can also calculate the displacement and velocity in two dimension as well, right? So we know the basic definitions already, but the numericals in 2D we have to solve it again. So I'll show you some numericals in all the situations and how to solve them in upcoming slides, right? So let's have a look at all these things, right? So let's understand these parts. So here we have it. So in 2 or 3 dimensional kinematics, everything is same, just I, J, K parameters you have to use, and whatever the understanding of vectors you have developed, that understanding you have to apply, right? For example, when you have to calculate the displacement vector, right? So how will you calculate the displacement vector? Right now the particle is moving from A to B, right? So the position vector of A, right? The particle is moving from A to B. So this is A. The position vector of A is OA. OA vector. You know that it is AX I cap and B BY J cap. Let us say it is given like that, right? And this is B, right? Position vector of B is also given, right? Something like that, right? So now you want to find out what will be the displacement vector. You are moving from A to B. So the displacement vector is going to be represented by this vector. This is going to be the displacement vector, right? The displacement vector will be represented by this vector AB vector. I believe the idea is very, very clear, right? So what will be the AB vector? How will you find that AB vector? My dear kids, here OA vector, let us say that OA vector or R1 vector, OA vector or R1 vector, this point is x1, y1, this point is x2, y2. So R1 vector is simply x1 I cap plus y1 j cap, and R2 vector is x2 I cap plus y2 j cap, right? No problem with that, right? R1 vector is given and R2 vector is given like this, right? Now you have to find out what will be the displacement vector, this vector. So it is going to be R2 minus R1, R2 minus R1. So to subtract these two vectors, just subtract the coefficient x2 minus x1 I cap and y2 minus y1 j cap. This is it, right? R2 minus R1, that is going to displacement vector, or simply subtract the coefficients, right? Have a look into the situation. If a body gets to displace from 0, 0 to 5, 12, then the magnitude of displacement is. So right now you see that we have to calculate displacement, but the particle is moving from point A to point B, right? And that is moving in 2D space. So again we can do that. 0, 0 to 5, 12. So 0, 0 is means 0 I cap plus 0 j cap, right? And 5, 12 means 5 I cap plus 12 j cap. All right. So just you have to find out R1 vector is given this, R2 vector is this. The displacement vector is always R2 minus R1. Subtract the coefficient, 5 minus 0 is 5 and 12 minus 0 is 12. All right. So that will be your answer, right? 5 I cap minus 12 j cap, right? R2 minus R1. So yeah, this is going to be your thing. Okay. This is going to be your thing, right? All right. I believe the idea is very, very clear, right? There is no problem with that particular part, right? Okay, it is plus 12 minus 2. Okay, now it is correct. So here we have to find out the magnitude of displacement. So magnitude of displacement is going to be under root coefficient of I square, which is 5 square, which is 25, and coefficient of j square, which is 12 square, which is 144. So under root 169 or 13 will be the answer, right? So 13 will be the answer. Option D is going to be the correct option, right? So I believe the idea is very, very clear. And if there is any question or confusion, you can definitely ask me, right? Have a look into this situation. Have a look into this situation. If a question is saying that if a body moves from 1 minus 1 and passes through all these points and goes back to 1 minus 1, its displacement is. Now think about it. We are talking about displacement and all this data is given. But the displacement only depends on initial point and final point, and all these points are irrelevant. Had they been given 1 minus 1 and 5 comma 4, right? If the particle is moving 1 minus 1 to 5 comma 4 eventually passing through these points, right? Then we would have calculated the displacement based on these 2 points only, because the path doesn't matter when we are calculating the displacement. So these points don't matter at all. Here, however, what is happening, initial and final points come out to be same. And if initial and final points are same, doesn't matter, the displacement is going to be 0. Right, so option C is going to be correct. Right now, let's talk about this part, average velocity and all these parts. So what is the average velocity? So average velocity is rate at which the particle is moving. So it is delta r upon at. So we have already talked about that part. Let's have a look at numerical, how the numerical would look like. Right, so this is the average velocity, right? Just calculate the total displacement upon total time, right, like that. So let's have a look at that first of all. So right now we already know that in the previous class we have seen, right, if we are taking the components of displacement, we will get the velocity. We are taking differentiation of displacement, then we will get the velocity. Differentiation of velocity gives us acceleration. So this is the basic calculus, we already know of that, right? Look into this numerical. The position vector of an object changes from 3i plus 4j to 9i plus 12j. So from one position to second position, particle is going in 2 seconds. Its magnitude of average velocity is, so average velocity, so far you know that the formula for average velocity is displacement over time, right? So what will be the value of displacement in this situation? It is moving from here to R2 minus R1. So coefficients just subtracted. 9 minus 3, that is 6i, right? And 12 minus 4, that is 8j. Time is 2 seconds. So it is 3i. It is 3i plus 4j, right? This is the average velocity vector. All right. You have to find out the magnitude of average velocity. All right. So it is going to be under root this square plus this square. So under root 9 plus 16, which is under root 25, which is 5 only. Right? So option A is the correct option. No problem with that. An object is moving 15 meter east and then 8 meter north in 4 seconds. The magnitude of average velocity of the object is, an object is moving 8 meter north in 4 seconds. So basically it is moving 15 meter east, 15 meter east, right? 15 meters, all right? And then 4 meters and then 8 meters north in 4 seconds. Then it is moving 8 meter north. And it is doing all of that in 4 seconds. What will be the magnitude of average velocity? So we don't have to calculate it by graphical method. No worries about that. So basically 15 meters toward east, that is 15 I cap. And then he is moving 8 meters towards north, so 8 j cap. This is the total displacement, right? This is the total displacement vector, right, or r vector, right? It is covering that displacement in 4 seconds. So what will be the value of average velocity? So average velocity will be r vector, right, upon 4. And magnitude we have to take. So magnitude of r vector is under root 15 square plus 8 square upon so we will take the magnitude after that, so that will be better, right? So magnitude of this thing, so magnitude is 15 I cap plus 8 j cap upon 4, right? So this is it, right? So let's continue on solving it. So you have 15 by 4 and 8 by this thing, 4. 15 by 4 I cap plus 8 by 4 is 2 j cap, right? This is going to be the average velocity. Magnitude of average velocity you have to find out. So magnitude of average velocity is under root this square plus this square. 15 by 4 square plus 2 square. That's it. Just solve this particular part and you'll get the answer, which is option 4. So whatever that is, so solve this particular part and you will get the answer. I believe the idea is very, very clear, right? So yeah. So, or you can simply do that as well. Delta R, you can find the magnitude of displacement, right? And then divide that by time. Both of them are correct things, right? You can either divide that, you can either get the average velocity vector, which is the average velocity vector is displacement vector over time, right? So displacement vector over time and then get the magnitude, or get the opposite thing, right? You can also do in this particular fashion, right? You can also do this way, get the magnitude of average velocity, which is the magnitude of average velocity, which is why you have removed the vector sign. Magnitude of average velocity you can get 17 and then divide by time. Both of them are correct things to do, right? Now you have the acceleration, right? Acceleration is rate of change of velocity, right? If they are giving you the, let's say, the displacement, then you will differentiate to get the velocity, and then you further differentiate the velocity to get the acceleration. So this is how you can write down the acceleration, ax I cap plus ay j cap. All right. So here you have it. Look into this question. The x and y coordinates of a particle in planar motion is x is 5t minus t square and y is 10t. The acceleration of the particle at t equals to 1 second is. What will be the acceleration of the particle at t equals to 1 second? So right now you have this thing. X equals to 5t minus t square, right? And y is equals to 10t. Y is equals to 10t. All right. All right, the acceleration of the particle at t equals to 1. What will be the acceleration of the particle at t equals to 1? First of all, differentiate the x, displacement in the x-axis, get the velocity in the x-axis, right? Right. So it is going to be differentiation of that, 5. Differentiation of that, it is 2t. Differentiate it further to get the acceleration x-axis. Differentiation of 5 is 0, differentiation of 2t is minus 2 meter per second or meter per second square. So differentiation of that velocity in the y direction is 10. Differentiation of that is acceleration, which is 0. You see that acceleration x-axis is minus 2 and acceleration y-axis is 0, right? So what will be the acceleration of the particle at t equals to 1? So you see that acceleration of the particle is ax I cap plus ay j cap, right? Ax is minus 2, so minus 2 I cap plus ay j cap is 0. So this is going to be the net acceleration, right? Minus 2 I cap. Option A is going to be the correct option. I believe the idea is very, very clear. Now look at this situation. The direction of the acceleration in 2D motion is the direction of initial velocity, final velocity, changing velocity, none of these. You know that direction of acceleration. Acceleration is rate of change of velocity, right? So you see that the time doesn't have a direction. So whatever direction of change of velocity has, that is the direction of acceleration, right? I believe the idea is very, very clear. So acceleration has the direction of change in velocity. I believe this particular part is clear, right? Now, this was a simple exercise where we have simply understood how to look at these terms of motion when we are dealing it with 2D situation, right? So we can calculate the distance, displacement and all those terms in 2D as well, right? And after understanding all those ideas, let us now talk about the projectile motion, which is the biggest topic of this particular chapter, right? After completing the projectile motion, we can say that the most of the understanding of this chapter will be completed. We will also look at a little bit of problems of relative motion. Not very important from NEET perspective, but still sometimes it is asked. That is why I will cover it as well. Right. So that's pretty much everything. Let's move ahead and talk about the projectile motion. Right. All right. So let us now talk about the part 3 of this chapter, which is the projectile motion. Right. And this is the most important part of this chapter, needless to say. Now, in this part, we will talk about these things. First of all, we will talk about the projectile motion is nothing but it is a combination of two different types of motion. So I will explain you how is that and how to analyze it, right? So in many situations that you can only solve the problems of projectile motion when you understand these two components of projectile motion, right? So simply learning formulas are not enough in many cases, right? Then we will talk about the role of each component. I said two components are there. So what is the role of each component? Then we will talk about the terms of projectile motion like time of flight, maximum height, and the equation of trajectory of projectile motion. So these are all things that we will be discussing in this particular part, right? So without any further delay, let us start understanding about the projectile motion, right? So you see that what is happening in this situation, a bird is launched at an angle from the ground, right? So you see that when a body is launched at an angle from the ground, it will always exhibit a path like this, right? It will always move in a path like this, right? So this body is performing a type of motion called as projectile motion. So what will happen in the projectile motion? A body will be launched at an angle from the ground, and the entire motion, once the body is launched, then the entire remaining motion is influenced by the gravity. Right? So what is the force acting in this situation? We can say once you launch the body, when the body is here, are you pushing the body? When the body is here, are you pushing the body? Nobody else is pushing the body. Only one thing is there that is applying the force right now, and that is gravity, right? So in the projectile motion, what force is acting right now? We can say that the gravitational force is acting in the projectile motion, right? Now you know that the acceleration of the body is determined by the force acting on it. Yes or no? We know that from the Newton's laws of motion, that acceleration created by the body by a given force is acceleration is force over mass, right? So a force F acting on the body will create an acceleration A, right? So you see that here only acting force is gravitational force. So you see that the only acceleration that will be acting on the body is due to the gravity, right? So you see that. So let's have a look at that. So you see, in the projectile motion, we have two possibilities, right? Two possibilities, as I said, the projectile motion is nothing but a combination of two different motion. You see that a body is launched at an angle right now, and it is, let's say, dropping over here. So this is how the situation is going on. And let's say that this is the body moving at an angle, or let's say the velocity over here is v, right? And the velocity at which you have launched the body was, let's say, v naught, right? Okay. Let's say you are launching the body at an angle theta. So clearly, when you launch a body at an angle theta from the ground, it will perform the projectile motion. And this is happening under the action of gravity once it is launched, right? So right now you see that, there are two possible components of the projectile motion. Let's say this is one component of the projectile motion, right? It is v naught cos theta. And the other possible component is this, right? It is v naught sine theta, right? So these are the two possible components of the initial velocity, v naught cos theta and v naught sine theta. Now you know that the velocity will only get affected when you are applying force on it. Yes or no? Let's say that the body is moving on the ground, right, with a velocity v naught, and there is no force acting on the body, right, that can influence this velocity. So now tell me, if there is no net force acting on the body, can I say that the velocity will not change? What is this? We can say that this is Newton's first law, or law of inertia. If the net external force is acting on the body is zero, the body's state of motion will not change at all. So if it is moving with velocity v naught, it will continue to move with the same velocity. Now you tell me, let us analyze the horizontal motion. Let us analyze the horizontal motion, right? So when you look at the horizontal motion, and I ask you what is the force acting on the horizontal axis. Let's say this is x-axis, right? So what is the force acting along the horizontal velocity? So we can say that there is no force acting in the horizontal velocity. When the body is here, 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 anywhere else, there is nothing that is pushing the body in the horizontal direction, right? So we can say the force in the horizontal direction, my dear kids, is zero. And since the force in the horizontal direction is zero, no force means no acceleration. Acceleration in the horizontal direction will also be zero, right? Let us say that this is the x-axis and this is the y-axis. Horizontal is on the x-axis. So right now we can say that there is no force on the body in this situation along the horizontal. So the velocity along the horizontal of the body will not change, right? So I believe the idea is very, very clear. Right. So let us move ahead, and here we talk about this particular idea, right? So you see that if you analyze the vertical motion, however, right, if you analyze the vertical motion, however, we can say that there is a force acting along the vertical direction, which is there any force acting right now? Think about it. Is there any force acting in the vertical direction? We can say that along the vertical plane, when the body is here, 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 anywhere else, gravity is pulling the body downwards. Gravity is pulling the body downwards, which is why the body comes back to the ground. So yes, there is a force which is acting in the downward direction, which is the gravitational force, right? Gravitational force, or the gravity, is acting downward direction. What is the acceleration created by the gravity? We can say that acceleration created by the gravity, we can represent the acceleration created by the gravity with g, right? And now right now, because acceleration is a vector quantity, so we can say we can use the positive or negative sign depending upon the situation. So, but right now we can say that the acceleration in the horizontal direction is 0 and the acceleration in the vertical direction is g, right? Now think about it. Acceleration is rate of change of velocity, right? If in some direction there is no acceleration, means that component will not change, right? So you see that the horizontal acceleration is 0, so horizontal velocity will not change, right? Okay, so we can say that horizontal acceleration is 0 right now, so we can say that the horizontal velocity will not change. This is very important. Horizontal velocity will not change, right? Okay, got it. All right. And acceleration in the vertical direction is g. So we can say that the vertical component will change consistently. So we can say right now the vertical component will change, right? Okay. Now, if we have understood these ideas, then analyzing the projectile motion will become really, really easy, because horizontal component is not changing, horizontal velocity is not changing, the velocity stays constant. So what type of motion is it? We can say that that is uniform motion. That is nothing but uniform motion. So we can say that whenever we want to analyze the motion along the horizontal in this situation, right, so we can say that we can treat the horizontal motion as uniform motion. And right now you see that in the vertical direction the acceleration is constant, so it is uniformly accelerated motion. Acceleration is constant, so uniformly accelerated motion. So all three equations of motion that we had learned previously will be applicable here. In the kinematics we have learned it, right? So in the kinematics motion in one line, we know that there are three equations of motion, we said, right? So when the acceleration is constant, so uniformly accelerated motion is there. So right now we can say the vertical motion is constantly uniformly accelerated, so we can apply those three equations of motion, right? So this is what we have to keep in our mind. Okay, all right, so let's move ahead and talk about this idea. Okay, so right now this is the conclusion that we need to keep in our mind, right? This is the conclusion that we have to keep in our mind. So what is the conclusion? We can say that if we want to analyze the horizontal motion, we can treat it like a uniform motion. So you see that this is the first point. Horizontal motion is what type of motion? Motion is uniform motion, right? So you can say that simply distance equals to velocity into time, right? So you see that, let's say that how far the particle will go in the time t. So let's say that if the particle in the time t, how far the particle will go, we have to analyze the horizontal motion, right? So it is simply velocity, which is v naught cos theta into time t, right? So in time t, how far the particle will go, we can easily tell that, right? So now second thing is, whenever you want to analyze the vertical motion, for example, how high the particle will go, right, or for how much time the particle will stay up in the air, right, that is time of flight. So all those things we can calculate by analyzing vertical motion, right? So you see that vertical motion is uniformly accelerated motion, motion. All right. So I believe the idea is very, very clear, right? Vertical motion is uniformly accelerated motion. I believe there is no particular problem in this situation, right? So this is how you analyze the projectile motion, by breaking it down into two parts, right? Horizontal motion and vertical motion. And let me tell you again, right? Whenever you want to calculate the components that are along the horizontal, for example, the range of projectile, or they are asking how far the particle will go along x-axis. In that situation, you are analyzing the horizontal motion. What type of equations you will be using? You can say that you will treat that motion as uniform motion, and for uniform motion where the acceleration is 0, simply distance is equals to velocity into time is applicable, right? And whenever you want to analyze the vertical motion, that means you want to calculate how high the particle will go, or for how much time the particle will stay up in the air. We can calculate that by analyzing the vertical motion. And vertical motion is uniformly accelerated motion. V is u plus at, s is ut plus half at square, v square is u square plus 2as. Those equations we can use to analyze the vertical motion. I believe the idea is very, very clear right now, right? And having that cleared out, now we can move ahead and talk about the next idea, right? Having that cleared out, we can move ahead and talk about the next idea. The first thing that we are calculating right now is time of flight. What is the first thing we are calculating right now? We are calculating the time of flight. So time of flight is, what is that? Time of flight is nothing but the time taken by the projectile, or time taken by the body to complete the trajectory of the projectile. That is called as time of flight. For how much time the body stays in the air, basically, right? In the entire journey. Now think about it. If you want the bodies to stay up in the air, right, and we want to calculate that particular part, which part of the motion we should be analyzing? Should we analyze the horizontal motion, or should we analyze the vertical motion when we are doing so? We can say that time of flight means how much time the body stay up in the air. Because of the horizontal motion, the body will not stay up above the ground, right? It is only because of the vertical motion the body stays up, right? So we will analyze the vertical component of the projectile motion, right? So what type of component we have to analyze to calculate the time of flight? We will analyze the vertical component of the projectile motion. I believe the idea is very, very clear, right? In the vertical direction, the acceleration of the gravity is the acting simply, right? Acceleration is simply acceleration of gravity. And let us start talking about it, right? So here you have it. So you see that right now, you see that the vertical component is changing, and which is why you see that the size of this vector is changing every time, right? And you see that at the topmost point, the vertical velocity will become 0, right? So if somebody is asking that at the topmost point, what is the velocity of the projectile? We can say that the velocity of the projectile is only because of the horizontal component, right? Vertical velocity component becomes 0, right? Okay. And then the velocity changes, the direction of velocity changes, and it increases in the downward direction, right? So right now, as I said already, we want to analyze the vertical component, right? So let's say that there are two parts of the projectile motion, from the starting point till the topmost point, and then from the topmost point till the end, right? You see that velocity initially was in the upward direction. We will have the same velocity at the end of the journey in the downward direction, right? But if to simplify it, we analyze the motion from A to B first. So what can happen? At the point B, the vertical component of the velocity is 0. Right, at the point B, the vertical component of the velocity is 0. So we can simply apply it, right? analyzing the motion from A to B, analyzing the motion from A to B, right, in the vertical direction, right, in the vertical direction. So we can apply the motion in the vertical direction because vertical motion is uniformly accelerated motion. So apply it. V equals to U plus AT, right? V equals to U plus AT, right? We can apply it. So right now, initial velocity, because we are applying everything in the vertical direction, so everything should be placed in the vertical direction, right? So every component we will be using in the vertical direction, right? So initial vertical velocity, Uy, initial vertical velocity is V naught sine theta, right? Because it is launched with a velocity V naught at an angle theta. So it is V naught sine theta, right? Plus Ay. What is the acceleration in the vertical direction? We can say acceleration is acting downward. So we can say acceleration is minus g. Okay. So from A to B, let us say the time taken by the body to move from A to B is t, right? Okay. So everything is written here. What is the velocity in the vertical direction after time t? We can say once the body reaches at the point B, the final velocity in the vertical direction becomes 0, right? The body cannot move any further in the upward direction at point B, right? So we have vertical velocity in the top, at the topmost point becomes 0. So Vy becomes 0, right? So right now you see that Gt equals to V naught sine theta. So time equals to V naught sine theta upon G. I believe the idea is very, very clear, right? Alright, so we have calculated how much time the body will stay up in the air from A to B. We want to calculate total time of flight. So we will say that whatever time it stays up in the air from A to B, we have to just double it. So for the total time of flight, it is the time of flight for A to B. So total time of flight, let us say, is t. It is 2 times of small t. So we can say that it is 2 times initial velocity sine of theta upon g. In some books, they are using initial velocity with the letter u. So 2u sine theta upon g, that doesn't make any difference. So you see that 2u sine theta upon g, that is the total time of flight of the body performing projectile motion. So let us have a look at this particular part, right? Okay, let's have a look at a numerical on that particular question, particular concept. So here you have it, right? A football player throws a ball with a velocity of 50 meter per second at an angle of 30 degree from the horizontal. So a football player is doing what? A football player is throwing a ball at an angle 30 degree with a velocity of 50 meter per second. All right. So it will perform projectile motion, right? The ball remains in the air for how many seconds? How many seconds? We have to calculate total time of flight. Total time of flight. So formula is very simple, right? 2u sine theta upon g. Total time of flight is 2u sine theta upon g, right? So we have 2, initial velocity is 50. We are launching at an angle of 30 degrees. Sine 30 is going to be 1 upon 2. And g, the value of g we have to take as 10. Right? So this 2 and 2 cancels out. This 0 and 0 cancels out. So answer is 5. Alright. So answer is 5 seconds. So option C is the correct option. Right? As you can see over here. Right? So let us move on and talk about the next part. Maximum height of the projectile motion. What will be the maximum height of the projectile motion? You are launching the body at an angle theta. It will go to a certain height and then after that it will start falling like this, right? So in this situation, again, are we analyzing the horizontal motion or are we analyzing the vertical motion? Like this, right? So you see that the body reaches at the topmost point like this. The body reaches the topmost point like this. So we are analyzing we are calculating the topmost height. We have maximum height of the projectile, right? Maximum height of the projectile. So clearly we want to analyze the vertical component of the motion, vertical part of the vertical component of the motion, right? So in the vertical direction, we can say that from A to B, again you analyze the motion from A to B, right? So we can say v equals to u plus v square is u square plus 2as, right, in the vertical direction, and everything is in the vertical direction, so y components are used. What will be the vertical velocity at the topmost point? We can say it is 0, so it is 0 at point B. What is the vertical velocity in the initial at the initial point? We can say vertical velocity, if it is u, so it is going to be launched at an angle theta, so it is u sine theta. Put it over here, and s is h, so displacement in the vertical direction is h, okay, right, and acceleration in the vertical direction is minus g, so put it over here, and h will come out to be u square sine square theta upon 2g without any problem. So h is the maximum height when theta is maximum in this situation. So we can talk about, if you are launching a body at an angle theta, this will be the height represented by the body in this situation. So clearly what is happening right now, right, you see that this is the height of the body when you're launching at an angle theta. But for all possibilities of launch angle, right, you can launch at the 30-degree, 40-degree, 60-degree, 80-degree. For all possibilities of the launch angle, at which angle you should be launching, so you can get the maximum height. So it's a very common sense, we can say. So for height to be maximum, sine square theta has to be 1, and that is only possible when theta is 90-degree, right? So if you want the body to go at the highest possible value for a given velocity, for a given initial velocity, you have to throw it vertically, right? Because when you throw the body vertically, all the velocity is invested vertically, it will achieve the maximum height. Theta will become 90 and it will achieve the maximum height, right? Okay, so what is the maximum height? By the way, if this becomes maximum, that is 1. So maximum height becomes u square upon 2g. So height for a given launch angle theta is u square sine square theta upon 2g. If you are launching the projectile at an angle theta, the height it will attain, the maximum height it will attain is u square sine square theta upon 2g. And for all the possible values of launch angle, the maximum value you will achieve at an angle when you are launching it at an angle of 90-degree, and that maximum height is u square upon 2g, right? Okay, for a given initial velocity, you cannot achieve you can never achieve a height more than that, right, for any given angle, right? So let's move on and talk about the next idea. A particle is projected with a speed of 20 meters per second at an angle of 53-degree with the horizontal. Find the ratio of its maximum attained height to its time of flight. We have to find the ratio of its maximum attained height to its time of flight. So you know that you are launching a body right now at a velocity of 20 meter per second at an angle of 53-degree, and it is given sine 53 is nothing but 4 by 5, right? So clearly we can calculate that. We have to find the ratio of maximum attained height. So maximum attained height, you know that maximum height for a given angle is u square sine square theta upon 2g upon 2g, right? Okay, and you also know that the time of flight of the projectile, we have to find the ratio of these two things. The time of flight of the projectile is going to be 2 times 2u sine theta upon g. All right, now we want to know the ratio of these two things. We just have to divide it. So let's put the value over here, right? So it will be 2u sine theta upon g, right? So you see, g and g can be cancelled out, u and u will be cancelled out. So h upon t will come out to be u sine square theta upon 2. And here you see that this sine theta and this sine theta can be cancelled out as well. So you will have u sine theta that will remain upon 2, right? And that 2 you will become over here, right? And there is nothing to go up. So u sine theta upon 4 will be the final thing, right? Find the ratio of its maximum attained height to its time of flight, right? So this is what we can do easily, right? And you're launching at an angle of 53 degrees, so sine 53 is nothing but 4 by 5. So in place of theta right now, we can place 4 by 5 over here as well, so we can avoid on a step. Sine 53 degree right? Sine 53 is nothing but 4 by 5. So I am placing 4 by 5 over here. I am placing 4 by 5 over here. So this and this will be cancelled out, right? So you have initial velocity. The u is the initial velocity, u upon 5. Initial velocity was given as 20 meter per second. So you can remove that and place 20. All right. So you see, so ratio will come out to be 4:1. I believe the idea is very, very clear. H upon T will come out to be 4:1. All right. So option B is the correct option. So let's move on and talk about the next idea. So the next question is asking the maximum height reached by a ball that is projected with a speed of 16 at an angle of 30 with the horizontal is. What will be the maximum height reached by the ball when you are launching at an angle of 30 degrees? So it is very simple question. We can say that the maximum height achieved by the ball is u square sine square theta upon g. Yes or no? Oh, sorry, upon 2g. Right? U square sine square theta upon 2g. This is the maximum height achieved for a given angle theta. And right now you are launching the ball at a velocity of 16. So it is 16 square sine square theta, which is sine square at what angle you are launching? 30 degree. Sine square 30 upon 2g. Value of g is 10. All right. So just solve it and you'll get the answer. Right. When you just solve it and you'll get the answer. So sine square 30 is 1 upon 2 into 1 upon 2. Right. Just solve it. And you have 16 into 16 upon 2 into 10 into sine square 30 is 1 upon 4. 1 upon 2 into 1 upon 2 is 1 upon 4. So, all right. So it is 160 upon 10. So answer is going to be 16 only. Right. So answer is going to be 16 only. 16. Okay. It is upon 2g. Right. So u square sine square theta upon 2g. Right. So it is 16 square sine square theta 1 upon 4. All right. 2g. All right. So it is going to be 2 into 10. You cancel it out. 2. So it is going to be 32 upon 10. 32 upon 10. So 32 upon 10 is going to be 3.2. 16 into 32 upon 10. That is going to be 3.2. I believe the idea is very, very clear. So that is going to be the horizontal maximum height achieved by the body in this situation, 3.2 meters. All right. Okay. So option B is the correct option, as you can see. Right now, let's move on and talk about the next question. So question is saying that a ball is projected at an angle of 45 degree with the horizontal with a speed of 20 root 2, right? This is the speed, right? Its height from the ground after 1 second. Now, this is a good question. This is a good question, right? All right. So you see, they are not asking about what will be the maximum possible height when you're launching at an angle theta with this initial velocity. No. They are asking you what will be the height achieved after 1 second. It is possible that the body is staying up for 5 seconds and after 1 second the body is here only. You are being asked this height. What will be the value of this height? But after 1 second, let us say the body is here and they are asking what is the height when the body is after 1 second. So now think about it. Its height from the ground after 1 second, we can calculate that by analyzing the vertical motion only, right? So simply do one thing, analyze the vertical motion. So here we cannot apply that particular thing. Here we cannot apply that particular formula, because that formula is applicable for the maximum height of the projectile. That formula is applicable for the maximum height of the projectile, right? But after 1 second the body could be here as well. So for that we are analyzing the vertical motion. So we are analyzing the vertical motion. So now in the vertical motion we can say S equal a vertical motion is uniformly accelerated motion. So S is equals to ut plus half at square. All right. So we are analyzing it in the vertical direction. So all the parameters will be in the vertical direction only. right? Displacement in the vertical direction. So after time t, let us say the body is at height h, right? So vertical direct displacement in the vertical direction is h. After time t, what will be the velocity? We can say that we are launch initial velocity. Initial u is the initial velocity, by the way, vertical component of the initial velocity. So you are launching at a velocity u. Vertical component will be u cos theta, right? So 20 root 2, it is going to be Vy is u sine theta. So 20 root 2 sine theta. At what angle you are launching? You are launching at an angle of 45 degrees. So u cos 45, right? So after time t, t is 1 second over here. All right. Plus half at square. What is the value of acceleration in the vertical direction? So we can say it is going to be minus 10, because minus g will be the value, right? And t is 1 second, so it is square of 1. Okay. So right now, so it is going to be 20 root 2. Sine 45 is 1 upon root 2 minus, it is 5 over here. So 20 minus 5 is going to be 15, right? So I believe 15 should be the correct answer, right? So let's move on and talk about this particular thing. So yeah, option C is the correct option, right? So you see that similarly, they can ask you any other parameter, right, for a part of the trajectory, right? So here they are not asking about the entire trajectory. They are not asking about the maximum height. So you cannot go back and use the same formula for the maximum height, because that is applicable for the entire projectile, right? Here you have to analyze a part of the projectile only, right? All right. Now let us talk about the next term of the projectile motion, which is the range of the projectile. What is that? Right. What is the horizontal range of the projectile? We can say, to calculate the range of the projectile, which part of the motion you should be analyzing? Is it the vertical component you should be analyzing, or the horizontal component you should be analyzing? We can say, to calculate the value of range, we have to analyze the horizontal component of the motion. Horizontal component of the motion, right? And horizontal component is uniform motion. Horizontal motion is uniform motion, right? If horizontal motion is uniform by default, so we can simply say v is equals to distance equals to velocity into time, right? What will be the range, right? Total range you have to calculate in the total time of flight, let us say, was t. So for the time t, the body stayed up in the air, right? And think about it, for the entire time t, the body continued to move forward. So if the body started the horizontal journey, with a velocity u cos theta, so how far will it go in the time t if there is no acceleration? We can simply say u cos theta into t. So it is simply say that horizontal velocity, right? We can simply say that range equals to, because there is no acceleration in the horizontal direction, so we can simply say that range is equals to velocity in the horizontal direction, which is ux into time t, right? Okay, ux is nothing but u naught cos theta into tf, to time of flight, and you know that the time of flight for this projectile is 2u sin theta upon g. Just put the values and you'll get the range is u square sin 2 theta upon g. So now you know that for all possible angles of launches, right, for all possible launch angles, we can say for which of the possible launch angle the range will be maximum. We can say for the maximum value of range, this part should be 90, so that sin 90 could be 1. And this is only possible when theta is going to be 45 degrees. This is only possible when theta is nothing but 45 degrees. I believe the idea is very, very clear, right? So when you are launching at an angle of 45 degree, sine 2 theta will become sine 2 into 45, sine 90, and the range will become maximum. So what will be the value of maximum range? For all possible launch angles, the maximum range is achieved when you're launching at an angle of 45, and that value is u square into sine 45. You put sine 45 over here, so 2 into 45 is 1. 2 into 45 is 90, sine 90 is 1. So u square upon g is the maximum range. Yeah, or v naught square upon g, that is the maximum range, like this. Okay. So I believe the idea is very, very clear, right? Okay, let's move on and talk about this particular part. Okay. Over here, you see that for any given launch angle, the range is u square sine 2 theta upon g. All right. If you put, instead of theta, if you put 90 minus theta, if you replace theta with a 90 minus theta, think about it. What will be the new range you will get? In place of theta, if you put 90 minus theta, so 2 will go inside. You see that? In place of theta, if you put 90 minus theta, so it will become 2 into 90 is 180, and 180 minus 2 theta, right? 2 will go inside, it will become 180 minus 2 theta, right? So, right now you see 180 minus sine 180 minus anything is in the second quadrant. That is again a positive value. So sine 180 minus theta is again sine theta, right? So you can write sine 180 minus 2 theta is only sine 2 theta, right? So again you get back to the same formula, right? So if you replace theta by 90 minus theta, you get back to the same formula, means you get back to the same range. That means if you launch a body at an angle theta or at an angle 90 minus theta, that means if you're launching at an angle 30 degree or 90 minus 30, which is 60 degree. If you launch the body at an angle of 40 degree or 90 minus 40, which is 50 degree. If you launch a body at an angle of 20 degree, theta is 20, or 90 minus 20, which is 70 degree. In all these cases, the range that you will get is going to be same, right? In all these cases, at an angle theta and 90 minus theta, at all these angles, the range you will get is going to be same, right? Yes or no? So these are called as complementary angle. You call them as a complementary angle, right? So yeah, range is same if theta 1, theta 2 is summation of that is 90, or theta 1 is 90 minus theta 2. All right, so ball A and B are projected at different angles above the horizontal. Ball A and B are projected at different angle from the horizontal, right? So with the same speed and has the same range, if the angle of projection of A and B, A is 25, then what will be the angle of projection of B? So you see that velocity of projection is same for both of them. You are projecting them with a velocity V, right? For first one, you are throwing at an angle of 25 degree. First one you are throwing at an angle of 25 degree. At what angle the other must be thrown so that the range is same? So if the first one is falling here, the second one must fall over here only, right? So the range is achieved at two different, the range achieved exactly the same when you are launching at when you're launching a body at an angle theta and 90 minus theta, right? So if you're launching at a 25 degree and 90 minus 25 degree, you will achieve the same angle. So 90 minus 25 is going to be 65 degree. All right. 90 minus 25 is going to be 65 degree. That means if you're launching at 25 and 65, at both of these angles, if you're launching with the same velocity, you will receive the same range. Okay. But in this situation, the time of flight will be different. This body will stay up for lesser time and the other body will stay up in the air for a higher time, right? The maximum range of a gun on a horizontal terrain is 16 kilometer, right? In this situation, the maximum range of a gun is 16 kilometer, right? Okay. If G is 10, what must be the muzzle velocity of the shell? What must be the muzzle velocity of the shell? So what muzzle velocity means? The velocity at which the bullet comes out of the muzzle, right? Muzzle, right? So this is the gun. All right. So at what velocity the bullet is coming out of that particular muzzle, right? Let's say that is V naught, right? And the horizontal range is, the maximum horizontal range is given. That means the launch angle is 45 degree, right? And you know that the maximum range is u square sine 2 theta upon g. Sine 2 theta is 1 because we are talking about the maximum value, so it is u square upon g, right? So maximum range is 16, so this is 16. U is the muzzle velocity, u square, so what, that is same only. You are launching at an angle of 45 with the velocity u, right? So u square upon g, the value of g we can take as 10 over here. So it is going to be u square upon it is going to be 160, under root 160, right? It is going to be under root 160. So I believe the idea is very, very clear, right? So right now, just solve it and you'll get the final value, right? Just solve it and you'll get the final value. The range is given 16, u is given for u square upon 2g. Just solve it and you should be getting the final value. I believe the idea is very, very clear, right? I believe the idea is very, very clear. Now they are giving it is the 16 kilometer, right? So one thing we have to correct it over here, right? They are giving that it is 16 kilometers. So we have to convert in meters only. So, right? So this is one thing we need to do. We have to convert that into meters, right? Now it is correct. So u square, then it becomes very, very easy. 16, 1, 2, 3, 4, right? 16 10 to the power 4, or simply 4 into 10 to the power 2, or it is 400. The muzzle velocity is 400 meter per second. At that velocity, the bullet is coming out of the muzzle. I believe the idea is very, very clear. And yeah, option B is correct option, right? So this is one thing you need to do, right? Always remember that you need to convert everything in SI units, right? So let's move on and talk about the next idea. That is the equation of the path of projectile. Now, many times, right, they will ask you certain parameter after time t or something like that. And those kind of questions can be solved very, very easily if you know the equation of the path of projectile motion, right? So how can you do that? Let's have a look at this situation, right? So right now, what are we doing basically? Right now, what are we doing here? We are launching a body with the initial velocity v naught at an angle theta. So there is a horizontal component and a vertical component. No problem with that, right? Okay. Now what is happening? We can say that horizontal component is going to be this much and vertical component is going to be this much, right? We want to know that what will be the equation of this path, right? Equation of trajectory means what will be the equation of this path? Every shape can be represented by an equation, right? That equation is simply relating the x and y parameter, right? For example, if you put this value of x, right, when the particle is here, when you put this value of x, what will be the value of y over here? When the particle reaches here and you put this value of x, what will be the value of y over here, right? Just you need to put find a relation between x and y. So you see, to know the value of x, you can analyze the horizontal motion. To know a value of y, you can analyze the vertical motion. No problem with that, right? So you see the horizontal motion in the horizontal direction when you apply, right, s equals to ut plus half at square, you know that in the horizontal direction acceleration is 0. All right. Horizontal direction acceleration is 0 and horizontally the velocity is, initial velocity is u cos theta, right? So, and now you see that as x, what is that value of displacement? We can say displacement in the x-axis is simply x right now, right? So you see that the other part will become 0, right? And the displacement in the x direction will be after time t, it is u cos theta into t. Okay, v naught cos theta into t, right? What will the velocity, what will the displacement in the vertical direction? What will the value of y? So you see, displacement in the vertical direction, every parameter in the y direction. Displacement in the vertical direction is y. Initial velocity is in the vertical direction, it is Vy, which is V naught sine theta, and Ay is minus G, right? So you just put it, right? Okay, so you have X and you have also Y. All right, you have X and you also have Y. Okay, so now you want to find the relation between X and Y, so replace the value of time from this one. So time is, X upon V naught cos theta, so just do that. Right, so time we can get x upon v naught cos theta, and the value of time we can put in the second one and solve it. So when you do so, when you replace time from the first one, right? So time is x upon v naught cos theta, you will get the relation between x and y only. The time will be replaced, right? So it is x tan theta minus gx square upon 2u square sine square theta. The format of the equation is y equals to, let's say that this is a, and b, this thing is b, right? Minus bx square, right? So it is minus bx square. All right. So this whole thing is b, right? So yeah, so right now you see that it is ax minus bx square. What is the direction of this parabola? So the parabola will open in the negative direction of, this is the equation of parabola, and this parabola will open up in the negative direction of y-axis, right? So which is clear, right? It is opening up in the negative direction of y-axis like this, right? So this is how the equation of projectile can be written out. Let's have a look at this situation. An object is projected with a velocity of 20 meters per second, making an angle of 45 degree with the horizontal. The equation of trajectory is ax minus bx square, where where h is height, right? X is horizontal distance, a and b are constant. What is the ratio of a and b? What is the ratio of a and b? So now clearly we know that the equation of projectile we have understood, y equals to x tan theta minus this, right? And here they are saying that it is the equation of trajectory is ax minus bx square, ax minus bx square. We have to find the ratio of a and b. So we have this part in place of a and this part in place of b. Yes or no? By comparing it with the equation of motion, equation of projectile, right? They are saying that equation of projectile is ax minus bx, right? But the real equation of projectile is this. That means in place of a they are using tan theta, in place of b they are using g upon 2u square cos square theta, right? Then you have to find the ratio of a is to b. So just solve it. Let's just put the value of a. What is that a? We can say a is nothing but here the tan theta coefficient of x. And what is b over here? We can say, you see, the b is g upon 2u square cos square theta. G upon 2u square cos square theta. All right. G upon 2u square cos square theta. All right. So you have to find the ratio of a's to b's. Just divide them, right? Okay. So just continuously solve it now. So it's going to be time taking solution. A upon b is going to be tan theta. Instead of tan theta, you can write down sin theta upon cos theta. No problem. All right. And this whole thing will go up. So it is 2u square cos square theta upon g. All right. So this is it, right? So we are launching at an angle of 45 degree. We will put those values. So cos square theta, this can be cancelled out. Okay. Now you're launching at an angle of 45. Sin 45 is 1 upon root 2. And cos 45 is 1 upon root 2. So we have, or you can say sin theta, cos theta, and 2. So 2 sin theta cos theta is sin 2 theta simply. All right. And this u square is there. And in denominator, we have this g. Now you can put the values. We have very clear things. So we are launching with 20 meter per second. So square of 20 is 400. We are launching with at an angle 45. So sin 45, you put 45 here. 45 into 2 is 90. Sin 90 is 1. Okay, the value of g is nothing but 10. So you see that it is cancelled out. It is going to be 40. So the ratio is going to be 40 is to 1. 40 is to 1. So option D is the correct option. So I believe the idea is very, very clear. Right. So this is how you can use it. Equation of motion. This is how you can solve it. Let's have a look at one more problem in this situation. The maximum height reached by the body is 64. If the maximum height reached by the projectile is 64, if the initial velocity is halved, the new maximum height of the projectile is going to be. If the initial velocity is halved, what will be the new maximum height of the projectile? Now this is very, very easy question. So you know that the height achieved by the projectile is u squared sin 2 theta upon g, right? Simply you can say that the height achieved for a given angle is u squared sin square theta, upon g. For a given angle theta, the height achieved by the projectile is u squared sin square theta upon g, right? Okay. Right. For a given angle, the height achieved by the projectile is u square sin square theta upon g. The maximum height achieved is 64. And if the initial velocity is halved, the new maximum height is going to be. So h dash, initial velocity is halved. U square, that is how much? 64 meter. Okay. Right. And it is halved. So it is u by 2. So it will become u square by 4. In place of u, put u by 2. So it will become u square by 4. and the launch angle is G, right? Just divide it. Or you can say right now, no problem dividing and all, right? You don't have to divide and all. You can simply see that it is nothing, u square sine square theta upon G. It is nothing but the maximum height in the previous case, h upon 4, right? So it is going to be 64 upon 4, which is going to be 16. All right. So I believe the idea is very, very clear. The new maximum height is going to be 16. I believe that particular thing is very, very clear. Right. Okay. So let's move on and talk about this particular part. Right. Okay. All right. So let's move on and talk about the particular part. Okay. Maximum height. Okay. Answer is 16. But it should be 2G now. It should be 2G. Right, but that doesn't make any difference, right? U square sine square theta upon 2G, that should be the maximum height, right? That is correct. And for maximum height is achieved when the theta is 90 degree, but that is for all possible angles of projection, what will be the maximum height? Then you can say in that situation the maximum height is achieved, which is U square upon 2G, right? So this is correct. So that too I missed in the first part, but that doesn't make any difference because that will be cancelled out anyway. So yeah, so answer is going to remain 16 only. All right. Let's move on and talk about the next part. The question is this: the angle of projection of a projectile to have same horizontal range and maximum height is okay. So we want same horizontal range and maximum height. We want same horizontal range and maximum height. No problem with that. What will be the same angle of projection for the same horizontal range? What is the formula for the horizontal range? It is, if you're launching at an angle theta, right, with an initial velocity u, so it is u square sine 2 theta upon g. So you know that horizontal range is u square sine 2 theta upon g. Okay. All right. And maximum height. What is the maximum height in this situation? You know that it is u square sine square theta upon 2g. All right. U square sine square theta upon 2g. And why are we equating them? This is the maximum height for a given angle theta. Why are we equating them? Because we want, let's at an angle theta where these two things are same. So we have equated them. Okay. All right. So just tell that they are equal to each other. So range and height are same. So just to keep things clear. All right. So let's say that at an angle theta, we want them to be same. So let's solve it. G and G will be cancelled out. U square and U square will be cancelled out. Okay. So we have sine 2 theta, it is 2 sine theta cos theta. All right. 2 sine theta cos theta. Sine square theta we have upon 2. So this and this will be cancelled out, right? All right. So right now what will happen? This cos theta will go in the denominator, it will become tan theta. Tan theta will become equals to 4. So theta will become tan inverse 4. I believe the idea is very, very clear, right? So if there is any question or confusion, you can simply ask me out. So is theta is tan inverse 4. All right, so option D is the correct option. All right. All right, so this is pretty much everything about the projectile motion. Now, having completed the part of the projectile motion, we have achieved a very good clarity about the concepts of 2D motion and how to apply them. Now, let us move on and talk about the remaining concept and complete this chapter. So now let us talk about the final concept of this chapter, which is the understanding of relative velocity. So again, a very, very interesting and very, very easy concept to understand. And we will look at this, a very standard riverboat problems to understand this particular concept, right? So what do you understand by relative motion basically? So here we will talk about analyzing a motion of one moving object, right, from the other's frame of reference. For example, let's say that this object was moving with 50 meter per second, but you said that it is moving at 50 meter per second when you were stationary on the ground, right? Okay. But if you were moving, let's say, in the same direction of the object itself with 20 meter per second, then you would not say then that it is moving with 50 meter per second anymore. You will say that it is moving with a different velocity because your observation will change now, right? So what will be your observation right now? So right now, velocity of A with respect, let's say you are B, so with the velocity of A relative to B will be 50 minus 20. It is going to be 30 only. All right. If you are moving, let's say, 20 meter per second in the opposite direction, let's say, in this direction. So velocity of A with respect to B now, let's say A is moving 50 meter per second like that and you are moving like this. So right now you will say velocity of A relative to B is VA minus VB. Right. So velocity of A is 50 and VB is, this one is minus 20. So it will be 70. Right now you will observe the object is moving, A is moving at 70. So you see that a moving observes the same motion differently, and whenever we try to analyze a given motion relative to a moving observer, right, then we call that a relative motion, right? Motion is always relative anyway, right? So right now we will try to analyze it with the help of a riverboat problem, boat problems, right? So before we understand about the riverboat problems, you can understand few things, you can imagine few things. Here is the river, right? Imagine the river is flowing like this, right? And with it has a velocity, certain velocity 5 meter per second, right? Okay. Now, if you are moving in the opposite direction of the river with 10 meter per second, then you will not move 10 meters in a second. Understand that. If an object is moving 10 meter per second on the ground and you are observing stationary from here, right, you will say that he is moving with 10 meter per second. So in 1 second, the object will cover 10 meters. In another second, it will again cover 10 meters, right? So you see that it is moving with 10 meter per second. So in 1 second, it will go for 10 meters, right? But when you are observed from the reverse frame, in this particular situation, right? Let's say you are standing on the ground, right? And you see that object is moving, same object is moving with 10 meter per second, but the river is moving 5 meter per second like this, right? So river is kind of pushing it back. So effectively it is only moving 5 meter per second, right? So this observer sitting on the ground is observing the net velocity. So whenever we say what is the net velocity of the boat, we are observing it relative to the ground, right? So whenever you use the term net velocity of the boat, or we say net velocity of a person swimming in it. So the net velocity, who is observing the net velocity? The person observing net velocity, right? Because of the reverse flow, the person will be pushed back 5 meter per second. So in a second, the person will seem to be moving only ahead by 5 meters to the person standing outside. Yes or no? This person who was standing outside, right, he would observe 10 meters, the object is moving 10 meters if it is simply walking on the ground, right? But in this situation, what is happening? The river is also flowing, so the river will push it back, right? So he will effectively move only 5 meters in a second. So right now, the net velocity of the boat, this is observed by the person standing on the ground, right? Person is standing on the ground. All right, person is standing on the ground. Right? All right, so after understanding the net velocity, let's have a look at this thing. So there are other parameters as well. So here we have seen that VR is the velocity of the river, or the velocity of river relative to the ground. VBR is velocity of boat relative to the river, right? And VB is the velocity of boat relative to ground, or the absolute velocity of the boat, or the net velocity of the boat, right? VBR is also called as velocity of boat in the still water, right? So that is also clear, right? So if they are giving velocity of boat in still water, basically they are giving you this VBR, right? Okay. Now, if you want to write it out, the relative velocity, with the help of relative velocity concept, you can write down VBR is VB minus VR. I have just told you that. VBR is VB minus VR, right? So from that, VB is nothing but VBR plus VR, right? So net velocity is VBR plus VR, right? So yeah, this is the net velocity. Now this net velocity will be very, very important parameter when you are going to analyze the motion of a boat, right? You see that in the river boat situation, you want to cross the river, right? So certain parameters will be coming up in this situation, right? This is the river and you want to cross it. but because of the flowing river, there will be certain complications, right? You want to cross it straight, so you will go like this, right? And the river will push you like this. River is flowing like this, so river will push you in this way, right? So this is the situation that is happening in this situation, right? So now what is happening? VB equals to VR plus VBR, right? Now here you see VBX is this, right? Here you see the time, if you want to calculate the time in which it will cross the river, we will analyze one part of the motion, right? Think about it. Which motion is responsible for crossing the river? We can say that the motion responsible for crossing the river is this, right? Or you can say horizontal component VB r cos theta, and this is VBR sin theta, right? So you see that this horizontal component, this component along theta, right, this component is responsible for crossing the river. So whenever we want to calculate how much time it will take to cross the river, we will analyze using this component. And let's say that a boat is moving, a boat is moving like this, so river will push it, right? Let's say that this is the river, right? And the boat was moving like this, right? But the river is pushing it, so effectively the boat ends up like this, right? This is called as drift, right? The river is pushing the boat and causing the displacement along the direction of the river. The whatever displacement is caused, that is called as drift. So now think about this. Drift is affected by this component. Yes or no? Drift is affected by this component. Okay. So you see that if we have to analyze the time taken to cross the river, we will analyze using this component. If we have to calculate drift, we will calculate using this component, right? So here it is. So VBR is this. So X component we are calculating. So it is going to be this much, right? VB is VR plus VBR. We have just calculated that, this part. VB is VBR plus VR, right? So VBX, X component is going to be, everything should be in X component. VBR in X direction. What will be the VBR? The component of this thing along X axis is VBR sin theta. So just put it VBR sin theta. Similarly, in the Y direction, there is no river velocity in the Y direction. So the component of river velocity in the Y axis is 0. So this part will be 0, right? So VBR Y will be VBR cos theta. So just put it like that, right? So VBX and VBY we have calculated, right? The net velocity in the x-axis and net velocity in the y-axis we know, right? Now if you want to know that how much time it will take to cross the river, so it is width upon the net velocity in the y-axis, right? Width upon net velocity in the y-axis. So net velocity in the y-axis is this. So W upon VBR cos theta. This is the time taken to cross the river. And similarly, if you want to calculate how much drift will happen, so drift is going to happen because of the river velocity, because of the push of the river, I would say. So how much drift you will get? It is the effective velocity along x-axis VBX, which is this, right? And into time, right? For how much time it was drifted, or we can say that for the entire duration it was crossing the river. If the time taken was t, for the entire duration it was being drifting, right? It was being drifted. So the value of x is going to be VBX into time t, right? All right. So just multiply that and you'll get the value of drift. All right, so let's have a look at numerical and try to see that how to apply this particular concept, right? So here you see width of a river is 30 meters, river velocity is 4 meter per second, and rowing velocity is 5 meter per second. Okay, right? These are the parameters that are given to you. Now make the velocity diagram for crossing the river in the shortest time. Then find the shortest time as well, right? Then find the shortest time as well, and also net velocity of the boatman and drifting of the river. So you see that if you want to cross the river in the shortest time, how should you go, right? Should you follow the shortest path, right? So we can say that in this situation, the river will, the person will follow the shortest time, right? The river will, the person will cross the river in the shortest interval of time, right? You see that. If you want to cross the river in the shortest interval of time, then how should you move? You will move like this, right? You will move like this. The boatman should steer his boat perpendicular to the river current like this, right? In the shortest time. This is how it will happen, right? So the same thing will happen. If you want to cross the river in the shortest time, you will move perpendicular to the river direction like this. So this is the rowing velocity of the river. So rowing velocity, velocity of boat in the still water, or velocity of boat related to river, these are all the same things, right? So here it is. 5 meter per second. This is how you should move, right? Now the river is pushing it in this way. Person should move in this way for the shortest time. So the effective velocity, the net velocity will be in this way. The person observing on the ground, he will observe like this, right? Okay. So the time taken is width upon 5, right? No problem with that. That is going to be the shortest time. And now what will be the net velocity? So net velocity will be the resultant of these two. So under root this square plus this square is going to be under root 41. What will be the direction of the net velocity? Tan inverse y upon x. So it is 5 upon 4. This is the net velocity. No problem with that. How much drift you will get? How much drift you will get? So drift will be decided by this component 4 into the time. How much time it is taking? 6 seconds, right? So 4 into 6, that is 24, right? I believe the idea is very, very clear. This is one thing you have to keep in our mind, which part of the motion you have to calculate. You have to analyze and in this direction. So of course, this particular component you have to use, right? And you have to analyze how much drifting will you need to talk about. So of course, in that particular situation, you will talk about VR, right? The effective component in this direction, right? Okay. So let's move on and talk about this particular direction. Can the boatman reach the point just opposite on the other shore? If yes, then make the velocity diagram. So of course, if the boatman wants to reach, the river is flowing like this and the boatman wants to reach in this direction. If the boatman goes like this, he will always be drifting away. If he always wants to ends up exactly at point B, he has to steer away in this way and the river will push it to the opposite point, right? So at what angle he should move, this is the thing we need to calculate. So you see that he is clearly steering in this way, right? And he wants, the river will push him into this direction, right? Again, all the values we know that this value is 5, river velocity is 4, VB we don't know right now. The net velocity we don't know right now. So you see that in this triangle, the value of VB is under root 5 square minus 4 square, which is 3, right? So yeah, this will be the 3, right? So sine theta is going to be in this particular triangle. Sine theta is going to be 4 upon 5 base, so 4 upon 5. So you see that the theta will be 53 degree. Okay. Sine 4 upon theta is 4 upon 5. So sine inverse 4 upon 5 is 53 degree, right? And how much time it will take? So how much time it will take in this situation? So of course, it is total width upon the net velocity. So the net velocity right now, is 3. So just divide it by 3 and you'll get the answer, right? Okay. So finally, one part is there. They are asking how long will it take him to row 10 meters up to the stream and then back to the starting point. 10 meters up to the stream and back to the starting point. So in this situation, we can say that we have to calculate the total time. So total time will be time taken in upstream plus time taken in the downstream, right? Just have to add them up, right? So time taken in upstream. So you see that upstream means you are moving in the direction or opposite to the direction. Downstream, you see that. These are all the situations you have, right? Here you are moving in the direction or opposite. Here you are moving opposite to the direction, right? Or you see that in this situation, VB R is VB minus VR, right? So the net velocity you are achieving is an addition of these two, right? In this situation, the net velocity is an addition of these two. That means they are moving in the direction, same direction of river flow, right? And similarly, the net velocity will be subtracted when they are moving in the opposite direction, right? So here they are moving in the opposite direction. Got it? So clearly you can say that here in this observation, they are the person is moving in the opposite direction of the river flow, right? So this is the opposite direction of the flow and this is the same direction of the river flow. Time taken is simply distance upon velocity, right? So you see that here you have calculated the total time in the first part when it is moving upstream, second in the downstream, just add them up and you'll get the value of total time, which is 100 by 9 seconds, right? So I believe the idea is very, very clear, right? This was a simple idea about the relative velocity as well, very quick idea about that. So this is pretty much everything about this chapter, right? So there were 4 or 5 parts of this particular chapter. One more part will be there, my dear kids, that is circular motion. We will be having a separate video about the circular motion where we are going to talk about the topic in great detail, right? So having said that, keep a very good care of yourself. right? And just download the DPP and solve it after the class as well, right? I'll see you there in the next class. Till then, take care. Bye bye.